everyone, once again. I'm Tomasz, and I work at Allegro as a team leader. And today, together with Krzysztof, our senior software engineer, we would like to tell you the story of how we were fighting with the monolith in our iOS application. But first, before we start, let's move on to some details on what we are going to tell you in the next 30 minutes. So first we'll start with some context, historical context of Allegro, both for desktop and for mobile, so that you understand why the monolith appeared in our source code. And with that, we'll try to explain you the problems of monoliths, the problems we had when trying to scale it. And finally, we'll show you our current status. Krzysztof will tell you more about our current status, what we did wrong, what we are trying to improve, and what are our plans for the future. But first, so this is the agenda. But first, let's start with something. Let's go back in time, actually, to December 1999, when Allegro was released public. This was the time, probably most of you remember the time of the bubble for .coms. So lots of new portals appeared, and Allegro was one of them. And it was an effort of one person. So one person created Allegro. That had some implications, because the code that was created at that time wasn't thought to be scaled. So just to remind you, Allegro from that time looked totally different to what we have nowadays. Yeah, this was typical design of late 90s, so every web page looked like that. And the business model was also a bit different, because we were more focused on auctions. Now we are focused more on selling products like in a shop. And similarly, 9 years ago, Allegro for iOS was released. It was also an effort of a single person. And the truth is that the app looked totally different to what we have nowadays. So this was the era of iPhone 3GS. So iOS, I think that it was iOS 4 or 3, I don't remember. But the funny thing is that iOS version was released before the Android one. So we are first when it comes to mobile. And since that time, we grew really big. We gained lots of new users. And we also tried to scale the development process. There were some similarities between the backend world and the mobile world, because, for example, all of those platforms, the mobile, the desktop, the backend, throughout their life cycle, they experienced the change of technology stack. So for backend, it was, for example, migration from PHP to JVM. On Android, we still have the transition from Java to Kotlin, and similarly on iOS, we are still fighting with Objective-C legacy and migrating the code to Swift. So we've experimented with different repository models, like on the backend with monorepo. Then we've migrated to multi-repo. And in iOS, we were also migrating from monorepo to multi-repo, and then again back to monorepo, and I will explain why in a couple of next minutes. And yeah, and there were different worlds, but the problems were the same, because adding more and more developers was not scaling the process. Delivering more features took time, so basically we couldn't scale the process without rethinking the architecture. So different worlds, but same problems. And we're starting to consider how to scale our process. And in fact, we started first with the backend, so where we introduced microservices. So we tried to split that monolith into smaller parts, microservices. So we based our architecture on the backend using microservice approach. And the first microservice appeared in 2013. And to this day, we have more than 700 microservices. And they are mainly written in JVM-based languages. But we have also some microservices written in Swift. Two of them, and they are running on production. But that shows the benefits of this microservice architecture that allows us to use different technologies when they apply better. And similarly, on mobile, we also started to rethink our design, started to think about our design, how to split this monolith. The monolith that was started by one person, and then we tried to scale it, and the development process was not going as we would like it to be. So we started to introduce modularization. The modularization that we understood as a way to split our code base into modules, the modules that were dynamically loaded libraries. And we were inspired by some articles, something that was happening at that time. There was a nice talk about 3 years ago at Mobilization from Pedro Pinheira about microfeature architecture, and we were inspired by that, and we started to introduce those microfeatures and started to break the monolith. But why didn't the monolith stand the test of time? First of all, the monoliths, they promote strong coupling between classes. So like in this case, we have, for example, base view controller that is inherited by lots of classes, where we are supposed to put a lot of common functionality, but in the end, because it's a monolith, it's the class that is used everywhere, we tend to add their functionality that is not used everywhere. So this is some kind of code smell pattern that is named refused bequest. And with that, it is hard to scale the process because it's very easy to introduce some regressions, because the common base class is like a common point where magic could happen. And when you have a monolith, when you have hundreds of view controllers, then this doesn't scale really well. So similarly, you had lots of God objects. And we also experienced problem with encapsulation, because when you have one monolith, you have a single target, a single Xcode target. And with a single Xcode target, you have no difference between public and internal scope. So whatever you want to provide some kind of hermetization of the modules or the functionality, you can choose either between private or internal. And with that, it is hard to provide a good separation. And the layers of the application, they are simply mutually infiltrating each other, because we don't have this difference between public and the internal scope. But from the practical point of view, why was it hard to scale the monolith? First of all, it was hard because there were some common connections, common source files that were shared by large teams. So we had, for example, one project PBX file, shared localization files, shared assets. So those were changes that were files that were frequently changed, because usually when you develop a new functionality, then those files are affected at some point, and when you want to merge it, then there are some conflicts. And when you have a really sophisticated continuous integration, it can take time until these changes are merged. So we tried to address these issues. Similarly, another common thing in monolith is like global enums for example, for tracking, for some feature toggles where you aggregate these flags that are switched and the tracking values. And every time someone wants to add new functionality, probably it is added into some common enum, and it triggers some conflicts, and it propagates. In monoliths, we also observed complex delegates that were used to synchronize between different parts of the application. And with this complex delegate, it was very easy to introduce regressions. And of course, longer compilation times. Because we had a single target, we started introducing Swift. With one monolith, there are lots of interconnections within the same module, so incremental builds were triggering the whole recompilation of the project. So this was something that we observed when we started to add more and more Swift. So this was a critical point that persuaded us to introduce more and more modularization just to avoid it and shorten the compilation time. And last but not least, when we started to work on Allegro app with more and more people, we divided into teams. And with Monolith, it was hard to grant code ownership between different teams. So basically, when we split the app into modules, given modules were owned by certain teams. So it was, and the teams could manage the modules on their own. So it scaled simply better. Okay, so I already mentioned modularization several times because this is the way how we were trying to split the monolith. And in fact, in Allegro, we had several approaches towards it. The first one was horizontal approach. That is like a very straightforward approach because it's easy to divide the app from bottom to top, just cutting the different logical layers. And so we also started to introduce this approach in Allegro, where we started to extract, for example, utilities, networking, common UI. And in fact, this is a very typical approach towards modularization in lots of apps. And the problem of that was that the modules were not autonomous because inside mobile app, that was the main target, there were simply, the rest happened because there was all the business logic and there was the autonomy of this approach was not satisfying. So we moved to something that is called vertical approach. With vertical approach, we started to think about module as business features. So we started to extract certain business features into modules. Sometimes they were bigger, sometimes they were just smaller. It depends when we were working on that features. But generally, every new feature was introduced as a separate module. So for example, we had a listing module, search module, cart module, or some smaller modules like, for example, to handle notifications. This approach worked for us, but it had another problem that we started to introduce duplication in our app. So with duplication, there is more code to maintain, and we would like to avoid that somehow. So we ended up with a hybrid approach that mixes those two previous approaches, horizontal and vertical. And with that, we had some common frameworks that were used by the business frameworks, and it connected and it simply mixed the benefits, and also it reduced some disadvantages of the previous approaches. So to sum up, with different types of modularization, the hybrid approach was the best for us. It worked the best for us because it allowed us to reduce the regression risk, at the same time provide some kind of autonomy to the teams, and introduce reusability between the components that were in the shared libraries. But as you can imagine, with large code bases, there are no easy things, because the code base was started 9 years ago, so there was a lot of legacy simply inside it. So we had some challenges that we were trying to address. The first one was intermodule communication, so how to communicate between different modules, because when we have lots of modules, then we have to invent some way to pass the information between those modules. And we considered several approaches. Krzysztof, in more details later, will tell you which one worked for us. I will just go through them so that you know what we also considered. So the first was proxying through the app delegate. So the module, whenever it wanted to invoke something in another module, it invoked a call through the app delegate, and the app delegate dispatched this call to a corresponding module. This is like the straightforward approach. Then we also considered bridging frameworks, the frameworks that are extracted to have some contract between the modules, and that bridging frameworks could be imported into modules, and from the outside we could inject the implementation. We also considered deep links, so some kind of string-based way of passing information. In fact, it worked for us in certain scenarios involving, for example, mapping the URLs that are known on the web. So, for example, go from the listing to offer details, where we could simply use deep links. And the last, something that inspired us from the backend world that we also considered. In the backend, we have a message broker in Allegro that is called Hermes. It's built on top of Kafka, and it provides a synchronous way to exchange the information. We considered similar approach using Notification Center, but we decided to discard it because the app could behave in an unexpected way, and also there was, simply it didn't work for us. And there were also some other challenges like dependency management. So first we started with CocoaPods and multi-repo setup. And it didn't scale because every time we wanted to release a new version of the module, we had to release new pod. We have to invoke pod update. There were conflicts in manifest files. So we gave it up. And we moved to native frameworks. And native frameworks in understanding that we have a workspace, monorepository, and modules implemented in native frameworks. And now we are looking forward to Swift Package Manager. Unfortunately, we can't use it nowadays because there are asset files that are simply can't be included in the Swift packages. And we also are considering some prototyping with Bazel, just to reduce our compilation time and because Bazel offers a way of caching intermediate outputs of the build phases. The dependency injection, Krzysztof will tell you in more details, so I will omit that. But we also suffered due to Swift and Objective-C interoperability, because as you can imagine, our project started a long time ago. There was no Swift at that time, so we still had some Objective-C legacy. Now we have about half of the code is already Swift, but still we have Objective-C. So with that approach and modules, if we want to intercommunicate between Objective-C and Swift, we have to make lots of things public and annotate them with Objective-C. And it breaks hermetization of the module. So it frequently happened that the module exposed certain API that we wanted it to be used by some other module, but we have to export also some things that were not needed, and it made the API less clear. Finally, there were some smaller and bigger problems to address, like splitting the enums that I already mentioned, asset catalogs, localization files, decoupling objects, and extracting, for example, parts of the GAD objects to corresponding modules. And the question whether to duplicate or generalize. We're afraid to generalize too early, but on the other hand, we were afraid of the duplication. So each time we had to find a balance between those two solutions. And inheritance that I mentioned in one of my previous slides. So this is the problem that we are still fighting, the common base class that is in the monolith that lots of classes are inheriting from. And with this base class, we either had to extract functionality to other class in order to make the other classes independent, or we had to deal with that a bit differently. So these are the typical challenges that we had to deal with when fighting with the monolith. The monolith that was started really a long time ago. And now Krzysztof will tell you more details about what is our current status and what are our plans for the future.
Yes, as Tomek said, I will start with some summary where we are, what's our current state, and what decision we've made when dealing with mentioned challenges. So we started with the mono project, and through vertical modularization, we came to a hybrid approach. And currently, we have 12 shared modules. Those are things like tracking, networking, SSO, so authentication, etc. Common, so some extensions, some shared tools, common UI kit related shared code, brand book with fonts or colors. We have also 18 business modules. We are trying to keep each autonomous feature in separate module. So we have things like card, registration, search, listings, and so on. Some of them are for big features which have multiple views like card or loyalty program, but also there are modules for really simple features like filters or notifications view. And in fact, notifications view is just a simple table view which displays received notifications. And when user taps in such notification, he or she is redirected to another module. But of course, we need one more special module, one to rule them all, our precious Allegro app. And this is the target. This is the module from which one we were in which one we were starting. There was that was our monolith, and we were extracting those modules from this one. So how we make our modules autonomous now? Till some time ago, what we were doing was just importing shared modules to business modules whenever they were needed, and we were using directly classes from them, and we were happy. There was no code duplication. Everything was fine, right? But in the same time, we are making strong dependencies between those modules. And for example, when some time ago we created a new networking layer, so written in Swift, it was really difficult to exchange those implementations. And in fact, currently we have two implementations of networking mechanisms. So we decided to change it, and now instead of importing, we are injecting them. We created another module, which is called module kit. Sorry. It's super thin. It has only declaration currently of networking and tracking. It has only protocols, no implementations. And this is what we are importing to business modules. And they are working only now on some abstraction, not on the concrete implementation, because this is injected in Allegro app when business module is initialized. In terms of intermodule communication, we choose routing through main target. And it looks like this that, for example, offer view exposes overview delegate, and this delegate is implemented in Allegro app because there we have information about all modules, so we can easily implement logic for a given request. And flow looks like this. When user taps a button on offer view, let's say add to cart, then offer view calls function did tap add to cart on its delegate, and in Allegro app we can implement this logic that cart should show view controller. We are also taking care of our process of building modules. And for example, we noticed that we have frequently issues with Xcode project files. I'm sure you know what I'm talking about. For example, merge conflicts, or maybe CocoaPods overwriting some settings. So we started to move those settings to Xcode build configuration files. Those files are easier to read, are easier to merge. and then they are not overwritten by any external tool. Another way of dealing with this issue is to use Xcode Gen. This is a tool for auto-generating project files based on YAML file and file structure. We have already some issues with this tool, for example, when switching between branches, but we see here a lot of benefits, so we would like to maybe work on some supporting solutions or tools. And CocoaPods is a really nice tool for managing dependencies, but we have many of them, so we noticed that big part of our compilation time is compiling pods. So we decided to move some third-party dependencies to Cartridge, which is using precompiled binaries, is compiling them only when they are downloaded, and then we are working on precompiled binaries, so it's much faster. And to speed up development, we are keeping unit tests, snapshots, and UI tests separately per module. So when we are working on some change in one feature, we don't need to run all tests from all app, and we don't need to build all modules. And we have also this empty test host. This is just target with empty, no other implementation and empty app delegate, so it's really fast to compile and run tests on it. Not everything went well. There were moments when we understood modularization in a wrong way, or we've made some decisions which were good at the moment, but they turn out to be hard to scale or maintain. And for example, our networking module, we started to put there all models, all information about endpoints, because we thought it's related to networking, so it should be in this module. But that was not the best idea. And now, for example, when we are importing such module to OfferView, we are getting also all classes related to card or loyalty program, which they are not needed there. Common CUI and common, as Tomasz said, it's the problem of generalization. We need to always think twice if if given tool or mechanism should be generalized or maybe duplicated. And for one example from our yard is a coupon view, which looks the same in loyalty program and card. So we decided to put it in common UI and use it in both places. But some time ago, we got a request that we should add a button in loyalty program to this coupon. Okay, it was implemented, tested, and merged. And during regression tests, someone found out that this button is also visible in card, where it's totally useless. So duplication could be safe for us in this case. And there was a lack of shared API between modules. So because of this, we were importing them to each other, and we are making strong dependencies. So they are not easy to change them, for example, now. So where do we go? What are our plans for the future, and how we want to develop our modularization? For sure, we need to send our networking module on some workout to lose some weight because it's too heavy now. We are moving out models and endpoint logic out from it and moving them to business modules where they are used and when they are needed. But because of this, we have some duplication. For example, offer model is the same in offer view and offer comparison. So some time ago, we started to incorporate GraphQL to our project. We have already in 2 modules. And it has this feature of auto-generating models based on JSON schema. So we think that it can help us in this case. And in the end, we would like to finish with a state where networking module has only logic about executing requests, and there is no implementation of models or endpoints. We want to also improve our intermodule communication, and we have 2 goals here. One of them, in given example, would communicate between offer view and cart. We were passing the big offer model, which is really, really big. It has like 20 properties. But cart is using its own model offer, so that was too much. It was too heavy, and what was needed really was offer ID, which is integer. So we are trying to modify our code, so it's using primitive types wherever it's possible. And we would like to give it a try with the approach of deep links. As a reminder how it looks now, we have this business modules, there is delegate, implementation in Allegro app, and when there is another module which would like to perform the same action, it also has its own delegate, and then again we are duplicating logic in Allegro app. So we think that deep links could help us. We would like to have another module, let's say called routings, and it would work in this way that business modules are registering for handling some deep links, and such configured module could be injected into business modules and they could work on it. So flow now looks like this, that again, when user taps this button, overview is calling routings with the handle URL method, and routings know which module is handling that URL, so calls on cart handle URL, and in cart we can implement this logic about showing view controller. And if another module want to perform the same action, once again we are just calling routings, so there is no code duplication. As I said, Allegro app is the module from which one we are starting. That was our monolith, and there is still some code which is waiting to be extracted to external modules. We would like to provide some demo apps for modules to speed up development, so we don't need to compile all Allegro apps. We can just compile a given module and fastly test or test our features. As I said, we are already moving some field dependencies from pods to cartridge, but we already see that the gain which we have from this is not enough because our team is still growing and code base is still growing and build time is still growing. So we would like to give it a try with Bazel. As Tomasz said, it has this feature of caching already compiled modules. And we know that companies like Pinterest or Lyft already are using Bazel, and they experienced a big boost with compilation time. So we would like to also try this. And of course, with creating new modules, we are keeping in mind all those ideas and solutions we came up with, and we are also modifying existing modules. So we already have few which are importing only module kit and brand book, and the rest is simply injected. So what we said today has been accomplished by work of many teams, and that was based on many years of our experience with the battle with the monolith. And not always we walk the correct path, but through next iteration we are trying to improve our process, our architecture, so development is easier to scale or maintain. And I guess we have a few more minutes, so we are happy to answer any questions if there are any.
Raise your hand. Yeah, wait.
Hi. Can you give like any real-life example on when you decided to duplicate some code, and when you decided to just reuse something?
So a good example could be the models that at some point we try to share them. So for example, we had a shared model between the offer details and the cart at some point, or listing.
Offer comparison, I guess.
Offer comparison, yeah, offer comparison. So we have a shared model, and then every time that someone wanted to change something in offer details, he has to modify the model, the common model, triggering the builds at the same time of another module. Yeah. So at some point we started to duplicate those modules so that the teams are independent of each other.
I'm just curious,
Could you describe how big percentage of your team is actually responsible for modularization, refactoring stuff, doing what you already told, fighting with the monolith against the ones that are doing the regular development?
So we have something what is called core team, which is working on some solutions supporting other developers, and this is a part of a work for this team, but also other things. But also what we are trying to involve everyone to maybe be part of this modularization process. So there is no strict split between this, and yeah. For example, now when I see some pull requests with networking, I'm always trying to ask people, hey, maybe use module kit because come on, one day we will have to do it.
Yeah, we started to define the good practices when we started doing the modularization, and now we are trying to persuade other people to apply them. Because the app is so big that it's hard to say that like one core team will fix everything. Yeah. So we want to distribute it. The core team defines the ways to go and tries to encourage people to apply those practices.
You mentioned about building only one module to test, and I'm just curious how you solve, because I think modules need some data. You mock it, or how you solve it to run just single module to test.
Yeah, we are stubbing the data. Yes.
So we are still. Okay, for example, for some mechanisms like networking, sometimes you are duplicating this module of executing requests, but for some other tools, we are stubbing them.
When you start building refactor your application, maybe you think about creating new separate framework, no, not framework, but use new technologies and not refactor old, but just creating something new and better based on your practices and your knowledge.
You mean new technology like React Native or Flutter or some new architecture or new app?
You currently maintain all your core, yes? You say that. And old core was built 6 or more years ago, and it's not really good for now. And you not think about creating new based on your knowledge?
Yeah, but you know, this is like, I think that every new programmer wants to do that, and look what happened to Netscape. At some point, they decided to rewrite the whole browser, and you know how they ended up. So I think that it's, everyone wants to do it, but in practice, you commit the same problems all the time.
But currently, you have many modules that you know that they work correctly, and maybe use them in new core of your application.
Maybe, but I think that we've chosen the way of evolution than revolution, and okay. Yeah, I think that we are too big to risk that.
Do you think we should care about modularization for such smaller projects, or it's a thing for like the big ones?
I think that every project should care about it. I don't know, Krzysztof, if you agree, but the problem starts appearing when you have large project. Probably if you are small, then it's up to you. You don't have to care.
Probably you don't think about this when it's a small project, but in the future, when project will grow, then you will experience some issues. So it's better to think from start.
Of course, there is some effort, some time that you have to invest it in order to build the tooling, build the way of splitting it. So for small apps, probably it depends on your time and if the client wants to pay for it. But for bigger apps or for the product apps, so the apps that has teams that are maintaining them, not apps that are just created and released and forgotten. Then I would say that it's the way that the industry is following.
Thank you. Good question.
You showed us different approaches to the modularization. Have you tried all of them, or have you performed like extensive research before deciding on the solution?
We tried all of them. In fact, we presented them in the order we started. So first we were extracting, for example, Metrum, which is the library to have some common components, UI components. Then we started extracting networking, or I don't remember because I was not working at Allegro at the time, but I just heard it. Krzysztof probably can tell you more details about that.
Wow.
But then we started to add new features using the horizontal, the vertical approach. And with that, we experienced some level of duplication. So we started to think whether we should put some logic into the common functionality, and we ended up with a hybrid.
I guess we have time for one more question.
We don't have more cups. I'm sorry.
Yeah, sure.
Here, in the
One
front.
more question.
Here.
Oh, here. Sorry. It's you.
I've heard that you had too much dynamic frameworks and you start merging them because I think iPad couldn't launch because of it. Can you tell a good number of dynamic frameworks we could have in project?
Well, I think that we haven't experienced any problems with dynamic. There was an issue with some version of Xcode when the number of dynamic libraries was big, the startup time was increasing because it was related to loading those libraries and calculating the addresses where the given functions are placed at the right runtime. So it had some impact. And people complained about it in Twitter. There was some discussion involved. Apple recommended not using more than 6 frameworks or something. But we didn't observe any issues with, and they fixed that at some point. There is also a new version of this dynamic library loader that doesn't have this problem nowadays. So I don't know any limit.
I don't remember such situation that we are merging them.
I read it on your blog.
Oh yeah, from Kamil, the post from Kamil, but I think it was from Kamil Bożym.
Could be.
Maybe there was. I don't know about any of these problems.
Okay. I don't remember.
Till now, we don't have any.
So you can have unlimited number of dynamic frameworks, and it should be okay, right?
I wouldn't say unlimited, but we have like 30 frameworks, and with 30 frameworks, we don't have any problems.
And you still think you have more, right? And it should be okay.
30 hour and then Cocoa Pods, then probably it's a bit bigger. But as you see what the other people in industry are doing, they are doing the same, and they have even more modules. So we are aware of this, but we don't experience that. We haven't experienced that.
Okay, thank you.
Thank you.
All right, that's it. Thank you very much.